Hi guys, welcome to another video. So this is Charlie from Vamos Gaming. Today we'll be looking at a video whereby I sort of like clean and apply liquid metal to a Radeon 6900xt, more specifically the Sapphire Nitro Plus version. So the 6900xt was released back in December 2020. So if we zoom in here, and back then it was during the height of the crypto boom or in the midst of the crypto boom. I think the height of the crypto boom probably was it was I think in 2021. So this particular customer, he did get his 6900xt during the crypto era, according to him. So it was pretty expensive, but that was the best the best AMD GPU at that time. It was almost trading blows with the Nvidia's 3090. Presumably not, because actually if you look at Tech Power Up's relative performance, actually the 6900xt is only trades evenly with the RTX 3080. But I would say actually it probably beats a 3080 in many situations, but loses out to the 3090 in certain games and so on. So all in all, it's still a pretty capable GPU. It's considered a mid-range GPU by today's standards because, as you can see, based on the relative performance chart, it's still performing almost evenly with the 4070 Super, and 4070 Super is still a pretty expensive and capable mid-range GPU like in modern day. So it's and the beneficial thing about the 6900xt is that 16 gigabytes of VRAM, and case in point is that this particular client, he's complaining he's actually using his his GPU for AI purposes. He's actually using quite a few AI upscaling software and sort of like to upscale and upres his photos. And the 16 gigabytes of VRAM actually allows him to use AI software. So even though he's not using an RTX or a Radeon card, it's still pretty capable. So his issue is that when he's using he's using his software, it's running into high hotspot temps. So like into the hundreds and so on, and the fan speed will ramp up. In my experience during my testing, the fan speed actually wasn't that loud, even if it's ramping up. So this is a pretty well built GPU. And as we can see here, during my testing with Heaven, it can ramp up as high as 102, 103 degrees Celsius. I forgot what's the max temperature, but it can run about pretty hot. So what we're gonna do is he requested for liquid metal, and we're gonna clean it to the best of our ability within like a few hours and apply liquid metal to it. Okay, so here I'll go through the quick disassembly. There are actually just a few screws. They are retaining it. Actually, to disassemble this GPU, I only realized after I reassembled it about 2 times that it's actually pretty easy. Like a lot of the screws I'm removing in this video is not necessary. Like the screws are actually like they are sort of like combining the PCB to the VRAM plate, and I ran into an issue here whereby I rounded one of the backplate retention screws, so I had to use like a WD-40 and like various different tool tips in order to remove it. So I had the same issue with a 6800 XT from Sapphire Nitro as well, where they're using really small backplate retention screws like the M2 screws, and it's really easy to round and very hard to remove. Because of the tension, it becomes too tight after many years. So and because of that small screw thread, it becomes really hard to remove. Eventually, I did manage to remove it, and I replaced it with one of my own like M2 screws, which I bought from AliExpress. They thread perfectly well, so I'm testing it out here. So I tested, okay, it threads well, and and that is that. Okay, so then we pry open the card. Be careful of and then I realized that actually there are 2 more screws in the IO plate that needs to be removed before I can pry open the card. So remove the fan cables, and there we have it. Yep, so the thermal paste actually is not fully dried. It's still a little bit sticky. So I suspect what happened was probably what we call a pump out effect, whereby there's some continuous pumping out of the thermal paste. Here I clean off the GPU fans with for damp cloth, and actually the GPU fans used to be transparent or translucent, but they've been so dirty and kicked with dust that they become gray. So after we clean it off, you will see that, yeah, it's actually the fins of the GPU fan is actually translucent and it actually has RGB on it. So the customer did say he was going to replace the GPU fans, but I only found out later that actually he wanted to replace the GPU fans because he thought they come with screws, because actually his GPU fan screws were rounded as well. But I told him that actually no, when I've actually have changed quite a few fans, GPU fans, and ordered quite a few from AliExpress. They do not come with screws. You have to order them separately from AliExpress. Okay, so here actually he requested for change of thermal pad as well. So I measured out. I forgot the exact size of the thermal pad. I believe they were around 1.5 or 1 millimeter. Yeah, I believe they were 1 millimeter. So I was using 1 millimeter pads, replacement pads, to try and change them. So after I removed the old VRAM pads, I just use a plastic scraping tool to scrape off the residue. Then I use isopropyl alcohol to clear out the rest of the residue from the VRAM. And then we'll replace it with, yep, our pads. So here I'm using some pads from AliExpress. They have no brand, but I've tested them and found them to be pretty decent, and they're pretty affordable as well. And I like them for their softness, because the pads are actually pretty decently soft. It's rated for 21 WMK or watts per metric Kelvin, I guess, but I don't know whether it's actually true. But the performance of the pads is quite decent. So I mainly like them because they are soft enough. So softer pads are more recommended because they're more compatible with a variety of GPUs. Because the problem with a lot of VRAM for GPU is that if you're using pads that are a little bit too hard, the cooler cannot compress properly, and if they can't compress properly, you won't get sufficient cold plate pressure between the GPU die and the cold plate, and that leads to cooling issues. So my preference is that usually the softer pads are better. So here actually I'm measuring out like the measurement of the fan screws as I'm taking out the fan. So I'm just showing them to the video, and I took a photo and I showed it to the customer. Like they were M2, how thick they are, the thread and so on. So it'd be easier for him to find a replacement. Okay, so I only took out one screw, and the screws were indeed rounded, but it was quite easy to take out, so he did not screw them in too tightly. As long as it's secure. Then now I've already cleaned off the so-called the cold plate earlier, which is copper plated cold plate. So there's no nickel plated, unfortunately, but we're still gonna apply liquid metal to it. So reattaching the heatsink back onto the fan shroud. Okay, and then use a little bit of tape to attach, like I believe that is a RGB cable or something. And here I'm actually using liquid metal, a cheap version of cheaper liquid metal from AliExpress, something like the LT100, around there. They don't really have a brand, they are OEM brand, but they work decently well, and they're pretty cheap to buy as well. So I first actually apply just a bit of liquid metal onto the cold plate on the heatsink, and take care to spread them out as evenly as I can. So the video is actually like sped up like 10 times. So in reality, actually, it takes me quite a few minutes. And earlier, actually, I really did like nail varnish insulation for the SMDs that's surrounding the GPU die. So the nail varnish has already dried up, which is why I'm now applying the liquid metal onto the GPU die. But I do not know whether the insulation is completely necessary, but I found it to be safe because with applying nail varnish as insulation to the surrounding SMDs, none of my GPUs have ever died from liquid metal. So yeah, it's a safety feature. Then I actually apply a little bit too much liquid metal. I removed a little bit of excess. Then now I reattach the fan cables, and we go to test, and we screw it in. Okay, personally, I prefer to screw in the so-called the surrounding screws before I put in the retention, like the retention spring or backplate mechanism, and always cross tighten when you are screwing down the area right around the GPU die, so that they ensure very even coverage for the GPU die. And then lastly, there's 2 screws for the I/O plate, and we do a final wipe and then we bring it to test. Okay, so this is actually after testing, after initial test, and I had to disassemble it again. The issue is that after the initial test, I think I found that there were hotspots. There were really high hotspots even after applying liquid metal. So it's a sign that the liquid metal application actually wasn't very even. So which is why I sort of like removed it. And yeah, so here, yep. So after I removed it, I used a clean cotton bud and I sort of like try and spread out the liquid metal again to ensure that there's even coverage of liquid metal on both the GPU die as well as the cold plate. And maybe I topped up a little bit more liquid metal to ensure that there's enough liquid metal so that there's no dry spots on or exposed spots on the GPU die because of those high hotspots. So this is why the insulation around the GPU die is important, because since we're applying a little bit more excess liquid metal, there is a chance of spillage. And we get to testing. So okay, so GPU is running fine. And here we can see that the GPU hotspot was greatly reduced. So from over 100, now it's down to about 85 to 86. The temperature delta between the GPU die as well as the hotspot is a lot smaller, which means very even spread of heat along the GPU. Okay, something to note is that during testing, while after I applied the liquid metal, initially the results after I applied liquid metal wasn't ideal. I was still seeing hotspots that hit up to like 90 degrees Celsius and so on, which was a little bit unnatural. So I did a little bit of tinkering and I realized that, okay, because of the slower, like the lower hotspot temps, the fan speed actually ramped down a lot after liquid metal. So the lesser fan speed could lead to higher memory temps, which I was seeing. Like I was seeing higher memory temps as well as decently high hotspot temps, even though not as hot as before. So this is a screenshot of what happened before. Like before I repasted the hotspot, like immediately ramped up to 100. And when completed the test, we could see that it managed to complete the heaven benchmark, but the highest GPU hotspot hit up to like 106 degrees Celsius, which is pretty hot. Memory temps are around 67, which is quite okay. But if you look at the GPU fan speed, the average GPU fan speed was about 2001 RPM. So my issue was that after I applied liquid metal, because of the lower temps, the fan was running for around 100,004 RPM, and maybe because of that, I was seeing a lot higher temperatures in terms of the GPU memory temps, as well as the hotspot temps were not as low as I wanted. So I went into the AMD Adrenaline software and I tinkered with the fan curve. So I made the fan curve a little bit more aggressive, such that to ramp up the fan speed to around 2001 or 2000 RPM basically. That means what the same fan speed as it was running before I repasted. So I adjusted the fan curve such that the GPU fan would run at 2000 RPM as long as there is a decent load. Like once the GPU die or hotspot exceeds about 70 degrees Celsius, it should ramp up to 2000. And after that, the results were a lot better. So after ramping up the fan curve, then I could get the result that I wanted, was that hotspot was around in the 80s, and the GPU memory temp was still slightly higher than before, but it was at least in the 70s. Like it was a few degrees higher than before. GPU temperatures was also is decent, so the die time was also decent. But the main thing was that the hotspot was a lot lower. Then and what else? Then the other components like the GPU VRM, the VR SoC temperature, VR VDD temperature, and so on. That means those are the temperature on the the voltage rails of the GPU was more in the 60 degrees as well, because previously when the fan speed was low, about 1004, the different voltage rails were running pretty hot, like they're running up to like 80 degrees Celsius, which is looks a little bit uncomfortable to me. So yeah, because before repaste, those rails were actually running in the 60s range. Then after repaste, they were like, after I applied liquid metal, I was like, how come the rails are now more running hotter at 80 degrees Celsius? So it's all down to the lower fan speed. So for any of the viewers who know, after repaste, you'll be like, oh, I actually see higher memory temps and higher let's say the voltage rail temperatures. So check your fan speed and make sure that the fan is maybe ramping up to a more aggressive curve that is running to the same RPM as before the repaste, so you can have a more apple to apple comparison. You can have a fair comparison that the GPU fan speed is not the variable that is ruining your test results. But overall, after adjusting the fan speeds, you will see that yeah, the results are about the same, but the Heaven benchmark scores are slightly higher after repaste by a few points. The surprisingly, the maximum FPS was a bit higher before repaste, whereby after repaste, the max FPS actually lower. Well, it is what it is, but still, mainly is, yeah, the hotspot temps are lower, and that's what we want. So the customer did actually test it out after he received his GPU. So he went home, he ran his AI tools, and he said great, because his AI tools now, they run a lot cooler than before, and he's really glad that the repaste actually helped. So he can now use his GPU for a lot longer, because previously he was actually thinking of spending like at least a few $100s to buy a 9070. So he mentioned that just this $30 spent with me to apply liquid metal and do a quick clean, as well as change of thermal pads, saved him like several $100s that he would have spent in order to upgrade his GPU. So he'll probably stick with the 6900XT for a little bit longer. All right, and that's it for this video. So we'll see you guys in the next one.